I'm excited about this tool. I should have slowed down a couple of decades ago and thought this out and built it. This is going to be a highly productive tool. And the beauty of it is it's just a very small amount of material, mostly shop scrap, and a little bit of hardware, and probably about an hour's worth of work. And now I have a tool that is going to help me be a lot more productive. Building the Smart Dado Pro begins with layout. It took me about 2 hours to complete it, but this is the prototype. What you see me build here will be different than the plans a little bit. The plans are improved. Also with the plans, you'll be able to build it in about an hour. Again, I started with layout. I picked out a piece of material that would, from my scrap pile, that would cover my needs here, and kind of took my time, laid it out, figured out what I wanted, and then I used the track saw and the short track to do most of the cutting, and then a little pull saw and a jigsaw to finish into the corners. I would do that different now. I would do a template and a router. In fact, I'll show you in a little bit, me kind of thinking about that and laying it out. I'm over at the router table now, which a lot of the stuff will be done there with the router. I first started by cutting the T-track with the T-track cutter that I recommend, the CMT that I'm currently using after trying a couple of different versions. Also, you'll see me where I stop cut. I didn't cut all the way through for the T-track, and in the plans you'll see that I pushed them all the way through. Found that to be better. Ultimately, I did that with mine as well. I just don't show that here. I moved over to the dadoes. The dadoes are for the splines that will ride in the T-track. When I set that up, I initially cut them a little too small, so the the spline wiggled a little too much in the T-track. So I recut them a little bit bigger. So I made them exactly the 3/8 or 10 millimeters that the shaft of the T-track cuts, and then made the spline match. And of course that's a little snug, but then I just moved them back and forth to sort of wear them out a little bit, and then they stay nice and straight, move smooth, and also did a little bit of waxing on them, which I don't show that here, I believe. Now I'm cutting the rabbet. This is the surface that the bushing of the router will ride on. So I'm cutting it 12 millimeters deep, but it's a little bit wider than I will actually need. I'll show you. I'll take the hand router and I'll do the final cut, which makes it exactly indexed to where you're cutting the wood. That'll make sense here in a little bit. And the rabbet is cut on the mirroring pieces, so both long pieces have the exact same cut. This exercise here isn't part of the build, and I'm recommending you do this if you want to be able to repeat this and also do it a little quicker. I am laying it out on a piece of 12 millimeter plywood to create a template. And then I'm going to just set it aside, and I'll go back to this later. In fact, I'll probably make a video showing you making the template and using it. But in this case, just like my videos in the past, if you take your time and make a template, it really, even for one time, it will pay for itself. And then you'll have it in case you want to make another one. I'm also templating the stop. The other pieces don't need to be templated, but these two will really benefit from having the ability to cut them with the templates with a router. In roughing out the parts, I made these rabbets where the bushing is going to ride, and the bottom part, which is going to be the actual cut, that I made a little bit bigger so that I can now cut it with the router, with the bushing on it, and it will trim it off to exactly where it needs to be. I'll do it on this one and on the mating cut here. I'm using a 1/2 inch router bit with a 5/8 inch bushing, but it doesn't matter. I could have used a 1/4 inch bit with a 3/8 inch bushing. As long as the offset, the outside diameter to outside diameter is 1/8 of an inch, that gives you a 1/16 for either side. If you're using metric, it's approximately 3 millimeters or 1.5 millimeters for each side. Bottom line is match the bit to the bushing, and then it will not matter in the future what bit bushing router combo you use. I'm cutting a really shallow dado for the scale to stick into. It's optional, but I like it because it helps the scale sit below the surface. It'll last a bunch longer. I just grabbed a couple of scrap pieces of plywood and tacked them on, and then again running just the bushing with the bit just barely cutting into the surface. And then of course I'm just going to double check it and make sure that it was deep enough. Now I'm gluing the splines into the dadoes on the movable portion of the jig, and then I'll clamp them in and let the glue dry up. You'll notice that I made those dadoes on the other side, the fixed side. That was a mistake, so you will not see those on the plans, but you do see them here in the video. I need to drill 3 holes. This is for the cam clamps to go through. They go through the 18mm material, they go through the dado, and they go through the spline. So I wait until the spline is dried so I can drill through all at once. And I use one of those little drilling blocks so that I know that I'm straight up and down. You see me using knobs here temporarily. I did not have the cam clamps, I had to order them, but in the final version assembly, you'll see that I have those blue cam clamps, which I use on everything since Kevin Criswell, one of the Smart Woodshop fans, pointed me to, and I don't bother with knobs and having to find a bolt head that won't spin in the track. I like this setup much better. It's faster, much more efficient. I'm gluing the T-track rail to the base left. This is the fixed portion of the Smart Dado Pro. Notice a couple of things that'll be different on the plans. One is the T-track rail. The T-track does not go all the way through. It does on the plans. In fact, I took it apart and redid it here on mine as well. Also, you'll notice the dados underneath that I did on the base left. That's not on the plan. It's not necessary. I didn't use it. Again, here I'm drilling the cam clamp holes through the base right. This is the movable portion, and also through the dado and the spline at the same time. It's important that you get it all together before you drill those holes. The overhead cam quit working. I didn't notice it, but we'll muscle through. I think you'll be able to see I'm almost finished here anyway. This is a little video from the promo video that I did showing how this thing works. So you notice it's 3 cam clamps, 2 of them on the movable right stop. You lift both of those and then it frees it up and it'll move in and out. The next cam, the third one, that's on the independent stop. That stop has a dado on it as well as a piece of material that sticks down and drops into the previous dado. By just lifting the clamp up, the cam clamp, I can just move that stop right on the scale, set for the exact spacing I want for the dados, and lock it down. And then there's an index on the bottom side of the stop that drops into the previous dado or the starting point. You just don't need a tape measure. You can get furniture level builds with this without using a tape measure. Be safe and productive in your smart wood shop. See you in the next one. Mahalo.